Chain rule happens whenever you have composition of functions. And actually, we've already kind of done a chain rule. When we did like the numerical base to the variable exponent, and we rewrite it, we log the base, and we derive the exponent, that's actually chain rule, because you get chains, little brackets. When there's bracket by bracket by bracket, that's a chain. So it's called chain rule. Okay? So, if I had something like this, and I wanted to derive it, d over dx. Now I have a function embedded in a power rule. Do you see that? Before I would have just had x to the n. We would drop the n in front, x to the n minus 1, and we would be done. Power rule, correct? Whenever you have a function embedded in any other type of power rule, quotient rule, chain rule, power rule, quotient rule, product rule, you actually have to do chain rule. So what does that mean? That means we work our way from outside in. So we just treat this f of x like it's just an x. How would I do the derivative of that? If this was just x to the n. N x to the n minus 1. However, x is not just an x, it's a f of x. So I just rewrite it in there. Now, your goal whenever you derive something, or you find the derivative of anything, is that you actually have to find the derivative of everything that's in it. So we've done the derivative of the exponent, correct? But we have not done the derivative of the inside, yes? So now we do the outside, and then we follow it with a chain being a bracket. Do you see how it looks like a chain? Chain link, chain link, chain link, chain link. This is a chain link. So it just looks like this. I believe you can stretch your mind to believe that that looks like chains. You guys are slowly. Okay, cool. So I love you all. Okay, f prime of x is what we would chain to it. Because what's the derivative of f of x? F prime of x, that's it. I didn't use any actual equations. That's a general form, right? For every single derivative. So, take away my little chains here. So what if I ask you then to do d over dx of 2x plus 3 to the 4? I have to work from outside in. So, what would I do for product rule first, or power rule first, sorry. The 4 would drop in front. I would get whatever this is to the power of 3, and I have to rewrite whatever that is. We agree? What have I not done the derivative of? 2x plus 3, that f of x in the middle, right? That's 2x plus 3. So I chain behind with the derivative of what's in that bracket. What's the derivative of 2x plus 3? 2. Can the 2 join the 4 because it doesn't have a variable or anything? Yes, they will make it join it. So it'll be 8 to the 2x plus 3 cubed. That will be your derivative. Let me box it because we're loud and proud. Chain rule isn't often done just by itself. Chain rule is often needed to do a product or a quotient rule because you'll have, say, this 2x plus 3 to the 4 multiplied by tan x or something like that, right? So in order to get the actual derivative of f, you actually have to do the chain rule. The chain rule is not usually standalone. Yeah.
Why don't you like put in the cube to product 3?
Sorry?
Like multiply 2x plus 3 3 times and put it in. Like combine it so you don't have that power.
It's not simplified, you expand. And we need a simplified form because we need critical numbers for the next unit. Okay. d over dx of 2x cubed minus 4x squared to the half, which is the same as saying the square root of all of that, right? Try it out. So we work our way from the outside in, so we're going to get 1/2. Rewrite it. 2x cubed minus 4x squared. Do you see how the derivative always contains the bracket? So just like when I told you when we take the numerical base to a variable exponent, so like 4 to the 3x squared, the first thing I do is rewrite it. So I'll be able to take it out. Yes? Same thing with chain rule. I will always have that whatever's in the bracket rewritten, just to a different number. So here I have 1/2 2x cubed minus 4x squared to the negative 1/2. And then derivative of the inside. So I get 6x squared minus 8x. Now, can this 6x squared join this half?
Yeah.
Yes. It can distribute through it, can't it? So we can get 1/2. I'm just going to rewrite it as a separate step in here so you can see it so I don't get a whole bunch of, what did you do? Some people. So it can't distribute through to the negative 1/2 one because I've done nothing. I just rewrote the thing. And if you're just doing this to me, yeah, you are. Cool. All right. This is to negative 1/2. So that one you can't distribute into because it has an exponent. We agree? But this one, its exponent is just 1, so it doesn't have one. So I can distribute the half through. And so I would get 3x squared minus 4x. Technically, I can move that whole thing to the bottom. We agree? Because it's a negative. So I can go 2x cubed minus 4x squared to the half. Is the numerator in the most reduced it could be?
No, you can take an x out.
You can take out an x. So we would get x, 3x minus 4. And then sometimes, depending on the answers in the multiple choice or in the actual textbook, they might turn this back to a radical. But if you turn something back to a radical, you turn them all back to radicals. So it just depends on their answers. Yes?
Take an x squared out of the bottom and then take it out of the square root.
Oh, you're being super efficient. We could do this. I like that. And then the x cancel with him. Oh my gosh, so many good things. So what Jonah said is you can take an x squared out of the denominator. Like you can literally just GCF it out. So you get 2x minus 4. And then the x squared can come out as a x. And then the x's can. There we go. Cancel. Then we're left with even prettier. An eraser just popped up randomly. Well, it's not. This board is testing Monday patience, and I don't have any. Oh, eraser. Now I actually need the eraser. If you so chose, you could just go like this. X is greater than 2. Yeah, but not equal. All right. Fun times. What if I give you this now? All right. So, when we do the derivative of trig, if it starts with a c, the derivative is negative. If it doesn't start with a c, the derivative is positive. That is not actual algebraic. That is just a way to memorize it. There's no like tactic. It does use, the reason why that does happen is due to actually deriving the derivative from equations. But what we have to do is we still have to do the derivative of sine. We work our way from outside in, correct? What's the derivative of sine? Cos x. So we're going to get cos 3x squared. What do you suppose we're going to chain to it? 6x. And then they'll often write it at the beginning. 6x cos 3x squared. Now I'm going to test you out and not tell you how to do this and see if you can do it. D over dx of secant 6x to the 5. I'll make it easier. I won't make it a numerical base. Try that one out. I wanted to test to see what you would do in this situation. So the derivative of secant x is secant x tan x. So I go secant x tan x. And then I get people wanting to do the bracket twice, the derivative of the bracket twice. Was there 2 brackets to begin with? No. So we only do 6x to the 5 how many times? 1. So what do we get for our derivative of that? 30x to the 4. And like I said, they usually write it at the front. So you just get 30x to the 4. Secant 6x5 tan 6x5.
I think like a 6 to the 4 out.
Nope. Because that's like a 30. That's like a 30 degree, or like a 2 pi radian or something. You know what I mean? So those angles, if you don't have them embedded with the secant or tan, they're just the word secant tan. Yeah. All right. Okay. Trying this one out. D over dx. Ready? Probably not, but you're going to have to be. All right. So I am going to give you the square root of 3x squared minus 4x times cos of, I'll be nice, 4x to the 3. Do I just derive each separately and call it a day? No. Do I realize that I have 2 things multiplied? Yes. And when I have 2 things multiplied, I have to do what? Product rule, because product is multiplication. So product rule, I call it power because I mix the p's up, but it's product rule. And so your f stays f, your g stays g, but your f prime is going to have to use chain rule, right? And your g prime is going to have to use chain rule. So you're not actually, you have to get your f prime, and the way to do that is chain rule. G prime, you're going to have to do chain rule. Try it out. So whenever you have the square root of any function, everyone paying attention? Whenever you have the square root of any function, you will have to GCF this way every single time. Okay? So we're paying close attention. So do you see how I have the square root of 3x squared minus 4x? I will have to be able to take a GCF out every time. And the reason why is because to simplify it, obviously, but also for next unit, I need to be able to take that out to get a critical number. If you don't take these out appropriately, the critical numbers are going to be really hard to find next unit when we have to find where it's increasing, decreasing, maxes, and mins. Okay? So I have F, I have G. F equals 3x squared minus 4x to the half to help myself out. F prime equals 1/2, rewrite it, to the negative 1/2 times 6x minus 4. Now this one is nice because I gave you one where the half and the 6x minus 4 join together and it gets rid of the ugly fraction. Right? They can go together and the ugly fraction goes away. If they can't, you actually have to pull that fraction out, which makes your life a little harder, but I didn't want to do that right now. So we are going to get 1/2 times 6x minus 4, so we're going to get 3x minus 2 as our one factor, because this can distribute through, because this is multiplication, it's a commutative property. I can move any of those multiplied things side by side, right? And then I have 3x squared minus 4x to the negative 1/2. Then g prime, the derivative of cos is negative, it starts with c, negative sine, rewrite it, 4x cubed, and then the derivative of 4x cubed is 12x squared, so I get g prime equals negative 12x squared, in a bracket, a chain, times sine 4x cubed. So I actually have to use the chain rule to find the derivatives to do the product rule. You see how the actual main goal here is product rule, right? So let's think about it. When we get to a question, we look at it, we say, what do I have to do to this question? I look at this question, I say, it's two things multiplied, I have to do product rule, right? So what rule are we using when we're doing this? Product rule. I just have to use chain rule to get the f and the g prime, but I'm not actually doing chain rule as my main event here. My main event is product rule. So d over dx of this equals. So when they put the d over dx in front, that just means the derivative of this, and then I go equal sign. G, which is cos 4x cubed. And I always simplify my derivatives before I plug them in. You don't want to simplify them in the middle of embedding them into something really ugly, right? So I get cos 4x cubed. G prime is negative 12x squared in a bracket, in a chain. GF, that's G prime. Good job, Lepp. So it's GF prime. 3x minus 2. 3x squared minus 4x to the negative half. Plus f. I will never use the radical one when I'm doing these. I always use the rational exponent. And then g prime. Now, does trig always result in a GCF? No, it only results in a GCF for the ones that actually have trigs that have the derivative. Like secant is secant x tan x, right? Cosecant x is negative cosecant x cotan x. So you'll be able to take cosecant out, you'll be able to take secants out, but when it's sine and coses, they'll be opposites, right? Yeah.
Is the 12x supposed to be squared? Like 12x squared?
Yeah, I just copied down wrong.
And negative sign?
Having a rough go. I wrote it, then don't. Oh no, it's not negative sine x. I put it on the 12. Like I have a negative here and I made it join the 12. So it's not negative sine x. Okay. Now, term 1, term 2. Most people can get to this spot and then they crumble. Okay? We don't want to crumble. Our next unit is impossible. Not hard, it's impossible. If you can't actually GCF out and simplify these, you can't find the critical numbers for next unit. All right. So, what can I take out of both of these? Well, this is a 3x minus 2. It's a negative 12x squared. Those are the only ones that I could correlate together. And is there anything I could take out of either of those? No, nothing better. I have a cos, I have a sine. Nothing I can take out of those. But I did tell you that whenever you take the square root of something, you will always have a GCF you can take out. Now, pencils down. Say I have this. X to the half minus x to the negative a half. I can take out a GCF. You can't put them together because they're not like terms and it's a minus sign, correct? I can actually take an x to the negative a half out. You always take the smallest one. So I would get x to the negative a half. We're not writing this because this has nothing to do with this question. I'm just showing you what we're doing. So when I take a GCF out, what mathematical operation am I doing? Division, correct? So if I'm taking x to the negative a half out of x to the half, I'm actually dividing them. We agree? So I'm saying off to the side, that would be x to the half divided by x to the negative a half. True statement? What is x to the half divided by x to the negative a half? It's x to the 1. Because what is a half divided by? What operation do we do if they're the same base? We're doing division, which means we actually subtract the exponents. 1/2 minus minus a half is 1/2 plus a half, which is x to the 1. So this would result in x to the 1. We agree? So when I GCF it out of x to the half, I get x to the 1. And then when I take an x to the half out of x to the half, what am I just left with? Not 0. 1. So it actually results in a nice thing. Because a half divided by negative a half is a half minus a half, which makes it 1. So whenever you actually have a chain rule with a fraction, you'll always take out the negative one, and the other one's exponent will always become 1 every single time. Because of the rule, power rule. The power rule was you dropped it in front, right, and then you reduced it by 1. So I put them together, it would always result in a 1. So what can I take out of here? I can take out a 3x squared minus 4x out of both of them, and I take out the smallest exponent. So what's the smallest between negative a half and a half? Negative a half. And then I write what's left over. So the one with the negative a half is the easy one. So I'm still left with cos 4x cubed. I'm still left with it being multiplied by 3x minus 2. When I GCF that out, I'm left with a multiplication of 1, right? Because they completely cancel when I pull that negative a half out. Does everyone agree with that statement? Okay, plus, what happens when I take a 3x squared minus 4x to the negative a half out of 3x squared minus 4x to the half? You just end up with this bracket to the what? 1. Because a half minus a half is 1. Do I have to show the 1? No, I'm just showing it for effect. And then I would have negative 12x and then sine 4x cubed.
Why isn't it 12x?
And I keep dropping the 2 off for some unknown apparent reason. I did it up there too. Here I could actually take out a what? An x as well. So if I want to, they'll take this, which is a negative a half, they'll drop it to the denominator, make it positive every time. So your numerator is going to be cos 4x cubed. 3x minus 2. 3x minus 2 is often written first because they write the polynomials first. I don't know why. And then we have this times a negative. So we could take an x out of this and we'd be left with 3x minus 4. They'll make this join this. So then we're going to get minus 12x cubed. Patience, my dear Watson, it's going to go to the denominator if you're wondering where the first thing went. There we are. And then sine 4x cubed. And then because that's to the negative a half, okay, we'll always write it down here. You're not wrong leaving it as a half. And what's better, matching the answer. So if it's a multiple choice, they might have it as a square root or your textbook, or they might leave it as a positive a half. If you left it as the root or you left it as a half, you're right in the written result. You can, but they're not going to be able to cancel off anything because it's embedded in a half. So you could have this as x 3x minus 4 to the half instead. But you can't cross off anything, you can't take out anything. Okay, I'm giving you another one. Bless you. F G prime F prime equals 1/2 2x minus 2x cubed minus 4x to the negative half times 6x squared minus 4, which is nice enough to let you have a nice one that functions with the half. So we get 3x squared minus 2 when you put the half and the 6x squared minus 4 together. 2x cubed minus 4x to the half, negative half. And then G prime E, you rewrite it because it's numerical base to a variable exponent. Ln the base, what is ln of e?
1.
Because it's just log base e of e, correct? So it's 1. And then we get 15x squared.
I definitely did something wrong.
So 15x squared e to the 5x cubed. All right. So this equals g, which is e to the 5x cubed, times f prime, which is 3x squared minus 2, times 2x cubed minus 4x to the negative 1/2, plus f, which is 2x cubed minus 4x to the 1/2, times 15x squared e to the 5x cubed. So term 1, term 2. Because there's an e or a numerical base to a variable exponent, we'll always be able to take one of those out because you rewrite it as your very first step. So e to the 5x cubed. Then I say I have 15x squared and 3x squared minus 2, which have nothing in common, can't take anything out of that. Then I have 2x cubed minus 4x to the negative 1/2, 2x cubed minus 4x to the positive 1/2. We will always have that because there's a chain rule in there. So we take out the smallest one, which is 2x cubed minus 4x to the negative 1/2. And we rewrite what's left over. So if I take the e to the 5x cubed out, it's gone. I have left with a 3x squared minus 2, and then I took out completely the 2x cubed minus 4x to the negative 1/2, so it's gone. This one I took out the e, I'm left with 15x squared. And then what happens when I have 2x cubed minus 4x to the 1/2 and I take out a negative 1/2?
It's just 2x cubed minus 4x.
Yeah, to the 1 technically, because the 1/2 minus the minus the 1/2 becomes a positive 1, so you just write it as no exponent. It will always work out that way. If you're getting something else, you are wrong. All right. So then we're going to be left with e to the 5x cubed. In the numerator, we're going to have 3x squared. Don't panic about this. It moves to the bottom. We talked about this last time. And then we actually distribute it through because the entire brackets now are all polynomials, correct? So be able to collect like terms. The other ones we had some other crap embedded. So here we get plus 30 x to the 5 minus 60 x to the 3 all over 2x cubed minus 4x to the 1/2.
I don't even know where I went wrong, but
Now inside my soul, I would want to rewrite that polynomial in descending order. It really doesn't matter. So I'm leaving it.
Wait, what difference does leaving it? Nothing combined, so why would you multiply the 5x?
Because you could possibly try and factor it now.
How do you know when and when not in this keep?
When it's polynomial. You can't like embed a trig. So if it was like 15x squared times tan of whatever, it doesn't fit together. This is polynomial and polynomial, so you can distribute.
Yeah, that's true.
Well, there's nothing else to simplify. You try and factor that. You try and factor a 30x cubed out? This is 4 terms, Clayton. You can't figure anything out. No, you can't. Well, yeah, but
What would be the best answer then? Just leave it as
No, you should do it here.
you should simplify it. You're going to be doing it with Aaron.
I'm gonna join the Air Force.
All right. I have homework on this page for you.
Best answer. Or like, I'm gonna
21 looks like this. Y equals x squared plus 1 over x squared minus 1 cubed. What do I have to do first? You have to do chain. Someone said chain. You have to do chain first. So you're going to go y prime equals 3. Rewrite it. To the 2. And then I have to do the derivative of the inside. What does the derivative of the inside use? Quotient rule. So you'll have a quotient rule behind it.
Okay, page
Right.
This is in, I'm giving you the page, it's from the blue textbook.
It's a G squared, which is